Hello, class. This is going to be about how to do question 9, since there's several questions similar to it. And so what we're going to do is we have this picture. Looks a little bit like a home base from like a baseball or softball game. And the graph above shows the base of an object. It could be the exact value in terms of pi of the volume of the object, given that the cross sections perpendicular to the base are semicircles with their diameters on the base. So think of like a bunch of semicircles. Okay, kind of a strange looking thing. And that means that we need to think about like, how do we find the area of those semicircles? Well, the area of those semicircles is determined in terms of their radius, right? So then let me just delete those semicircles for now, because now we want to think about our radius. So like sometimes we have radius there, different radii. Okay, so if I think about the radius function, r is a function defined by parts, where from 0 to 3, it is a straight line rising up 4. So rise over 1 is 4/3. 4/3 times x when x is between 0 and 3. And then it just stays constant at 4 when x is between 3 and 5. So from 3 to 5, it just stays constant at 4. Okay, so that kind of tells me the radius function of the graph. So then the area slices would just be the area of a semicircle is 1/2 pi r squared, right? Well, r is that thing, so the area is a function defined by parts, where it's 1/2 times pi times 4/3 x squared, and x is between 0 and 3, and it is 1/2 pi times 4 squared, which is 16, when x is between 3 and 5. I forgot. Yeah, there we go. All right, so let's simplify this. So area is, the first one simplified would be 16 over 9 times 1/2 will be 8 over 9. So 8 pi over 9 times x squared, or just 8 pi when x is between 0, 3, and 3 to 5. Okay, so then the volume will just be adding up all the area slices. So we'll take the integral of, so volume equals the integral from 0 to 5 of area. Okay, so that's going to be 2 integrals because I have a function divided by parts. So it's going to be from 0 to 3 of 8 pi over 9 times x squared dx, plus integral from 3 to 5 of 8 pi dx. Okay. So this one is take the integral, and I have 8 pi over something times x cubed. So I'm dividing by 3. So then I get 27 down here instead of 9, from 0 to 3. And then plus, and then this one is just a rectangle. So it's 8 pi high, and width is from 5 to 3, so the width is 2, so 16 pi. Okay, so then plugging in 3, you get 8 pi. Then plugging in 0, you get -0 plus 16 pi. I'm left with 24 pi. All right, let's see if that works. So bring this over here. 24 pi. So notice that if you spell just pi, it knows like, hey, I think you mean to put pi there. Oh dear. Okay, something's very wrong. I know what it was. I plugged into the wrong question. I was plugging into here. It's in number 9. I'm doing number 9 today. That's how today is going. All right, 24 pi. And when I do it there, it's right, of course, because that's the right question. That's the actual home base that I was actually doing. All right, that's how you do these problems. So we'll stop sharing, we'll stop recording.